Good afternoon and welcome to the journey on how we are future-proofing the United Nations. So before we start, I want you to introduce to the team. So Takshika, Sayem, Anne, and me, we bring different backgrounds, different experiences and know-how that enrich every step in this process. We want to also thank our sponsors, Jorge, Andres, and Manuel, for your trust and your collaboration through this process. Now, over to Sayem.
All right, so before we get into the problem, we just want to reiterate on one thing. We all know that UN holds an enormous amount of valuable information and data and knowledge, but so that's not the issue. The issue is being the unified access to that knowledge. So when we look deeper, we found that the information is spread across multiple SharePoints, folders, formats, and versions, creating the ecosystem very fragmented. Because these files also come from various internal and external entities, these don't have a standardized way of metadata and documentation. So even let's say an agent is going over their ecosystem and the file is being found, it just is very unclear whether the file the agent's picking up is current, accurate, or even consistent. And this is leading up to a lot of manual, repetitive work overload by the staff and a growing reliance on our information unit with a lot of repetitive questions. And it's clear that without a unified access, consistent metadata, and structured workflows, even the most advanced agent cannot reliably perform in the current environment. So to move forward, the UN does need a clear shared system of how the knowledge should flow, and just some Python code is not enough for that. We need to build a foundation to align people, processes, and technology where the information becomes findable, consistent, and ready for AI.
So with that, we want to show you a future where information is instantly accessible, consistent, and ready when you need it. What we are about to show you is a working prototype of AI agent that we designed for the United Nations. And let us show you what that looks like.
Built on familiar platforms to drive adoption, the query instantly hits the secure knowledge layer. The AI model processes the semantic meaning and retrieves the relevant data. Users can start with a single natural language question, just like speaking to a colleague. But the power of the system goes further. Each response becomes a starting point for follow-up questions. Users can refine, drill down, compare, or request summaries without starting over. To support speed and consistency, the platform also offers frequently asked questions, pre-built queries based on real operational needs. We provide instant access to high-value insights with a single click.
So we have focused on two main areas, the strategic meetings and programmatic activities, which often leads to high operational costs with decision making and also reporting. We also wanted to dive into this too because we wanted to give a prototype which can be replicated from day one.
So to design a comprehensive strategy, we designed this AI readiness framework consistent of 4 different layers. Each of these stock answers a different question. So how is knowledge structured, how it becomes operational, how people adopt it, and how can the system improve over time. All of these guided by a set of principles. So these are the stacks that we'll go on detail during this presentation. So before we spoke about architecture, information, or artificial intelligence, we established a set of principles that act as guardrails for any technical organizational decision that you will see next. So let's dig deep into what the knowledge architecture is. For any AI to work, we needed to understand how knowledge is in the unit. Without this layer, an AI will be the one scale and will just increase confusion. So this layer habilitates the organization to start working what they already have, this shared meaning, shared contract on how information is originated, distributed, retrieved, and stored. So we're going from individual to collective. So these are the different components that has to be worked on and that we have worked on for the blueprint on this layer. So first, we understood the information flow. In this case, the information started by the UN staff in different apps and different tools, and traveled and was stored and managed in SharePoint. But now we are proposing three new steps. These are ensuring that the information can travel from an individual mind or repository to being accessible for all users. We also understood the different use cases for the specific unit. Taking back what Takshika shared about programmatic activities and strategic meetings, we understood 4 different labels on how team members are retrieving and requesting information. And based on this, we designed the agent. So the agent is rooted in actual work and not only AI generic capabilities. So let's take a very specific, concrete example that staff members are asking themselves right now to run over the other components. Show activities by type delivered in Africa this year. So the schema is the opportunity to really explain how things connect to each other. And this will be super helpful, not only for the migration part, but how the agent will retrieve information. So in our example, project has a region, and a region has activities, beneficiary countries, type, and date. So schema is a structural backbone. Then metadata and taxonomy provide consistency and meaning. And this is where the dynamism of team members and workflows comes into equation. Team members can use different words, but the system will know that those share the same meaning. So for example, someone could type Africa with C or with K, and the system will retrieve the accurate information. And finally, the brains of the agent, semantic guidance and golden queries. So in the semantic guidance, the team member really reflected on the data that we received and the use cases and the information flow, and we understood how people in the team members are using the information. And based on that, we translated the rules and the heuristics and the rule of thumbs into a JSON, establishing like rules, for example, geography rules, date rules, and activity that will guide how the agent retrieve the information. And we also design a set of golden queries, and let's understand that as templates or validated formats so the agent can know what it has to retrieve. So the agent follows always governed logic. So by now, I've shared meaning and logic, and now Takshika and Sayam will share with you how can we enforce this knowledge at scale.
All right, so getting into the technical stack now. So what technical stack is, you can refer to as a platform, infrastructure, architecture. It serves as a backend foundation that supports the data, the model, and the user access. And before we go into each component individually, let's see a quick video on the whole system overview.
UN information starts in SharePoint. To make this data usable for AI, we run it through a structured ETL pipeline. We extract files from SharePoint, transform and clean the content to ensure consistency, and then load it into a standardized schema. The cleaned data is then migrated into Azure SQL. From here, the agent container retrieves information from SQL, interprets user questions using natural language processing, and generates accurate responses. Those results are delivered to staff through the UI container. All interactions flow through secure access and monitoring.
So going further, the technical stack, we have divided it into 2 segments. First is about making the infrastructure layer in itself, and second is building of the AI agent on top of it. So based on our research and our testing, we come up with 3 solutions for using a platform for keeping the data. Out of them all, we recommend the Azure SQL Serverless because it is easy to implement with 0 maintenance, and also it is more feasible option than the other 2 options, and the cost range between the containerized and SQL provision. So that's our recommendation. And then to have the data at a SQL, we would like to have a ETL process in place, and for that we used Azure Data Factory because it is a no-code, low-code kind of a tool, which starts at extract layer where the SharePoint, where the data is coming from SharePoint to the Azure Data Factory pipeline, and it is always constantly monitoring of what the files are coming, it is getting updated. There is a metadata which happens there. At transform level, there is what the standardization and data cleanup happens. So checking for null values, checking for the default values or negative values, or even correcting the date format, which is very much required for the agent. Those things happens at the transform layer. And finally, the clean table then goes into the final production ready database, which becomes a set for building the agent above it.
All right, so getting into the agent design right now, it's important to note that our agent is currently using the OpenAI API model, which is on the prototype, but it is also compatible with any other LLM provider. It work the same way, but the architecture right now supports the structured data, where the user query is interpreted into SQL and it gets the structured data, but it has the future scalability for RAG pipelines, embedded-based search, and MCP protocol for multi-agent collaboration. And this is a good way to look at how the technical layer and knowledge layer comes together, where the user starts with the questions, and with the schema in JSON, and with the help of the golden queries, which is the test cases or use cases for our agent, it is converted into NLP, from NLP to SQL. It goes into the SQL database, gets all the query, and then converts back into human-based output. And again, this is just to reiterate on how, on a quick eagle eye view of the prototype, the backend we're using is a SQL serverless container, and the agent and front end is in a Docker container. Agent, again, with the OpenAI API, and front end is being designed with the Streamlit UI, and which is a bunch of Python and CSS code. This is another one of the options that we would like to propose, which is the Copilot and Azure SQL. So in this setup, the Copilot handles all the natural language interaction, and SQL runs actual queries on live data. It's the similar architecture on compared to what we have in the prototype, which is open or vendor agnostic. And much of our existing work can be reused here, including the semantic rules, schema design, and the golden queries as test cases. This is particularly attractive for organizations who want to stay within the Microsoft environment, and yeah, it just complements from what we're proposing.
Okay, so now this is, we're moving to the third stack of the plan, which is adaptive adoption, and this is where our story shifts. We've shown you the architecture and also the technology behind it, but that's only half of the story. None of that works unless people and processes will evolve with it. So now we move into the part that basically determines whether the system succeeds in real life. So we were thinking about the change in 3 different levels: individual, team, and also organizations. With an individual level, staff learn small, repeatable habit, for example, just like tagging consistently or using the agent into part of their workflow. And then within the team level, the shift is basically about alignment. So share template, share metadata, and share processes as well. And then the third, which is the organization level, it's about formalizing roles and also governance, so then the system stays stable as it grows. And next, to help guide the adoption, we use the ADKAR framework because it's simple and also it's very practical for the UN context. The first is desire, meaning it explains why change matters. And then in the case of the UN, basically staff recognize that fragmented information, inconsistent metadata, and also manual searches will slow down decision-making and also reporting. The second is desire, means the staff see personal benefits. In case of the UN, it means that staff recognize how tagging consistently, using share template, and entering data properly will save them hours. And then the third, knowledge, is basically knowing how to work in the system. In this case, it's understanding where metadata goes, which taxonomy fields to fill, how golden queries guide the system, and how to use the UI for retrieving program activity information. And then next, its ability is basically applying those habits into real work. This is where staff actually use the assistant and to draft updates, validate information, and upload content with correct metadata and follow the standardized workflows. And last, reinforcement is ensuring these behaviors stick even after the pilot. And for the UN, this includes periodic reviews by data focal points, structured handover of updated taxonomies, and also lightweight governance that keeps the system accurate and then also sustainable. Next. Individual and team adoption can take you far, but long-term reliability requires structure, and this is where the governance enter. So we design governance to be lightweight because the unit doesn't need a large, complex apparatus. It needs governance it needs governance model that fits how the unit already works, and while also ensuring compliance with UN ethical AI framework that already set in place. Oversight ensures ethical and strategic alignment. Data stewardship protects data quality. Change control ensures updates are tested and also validated. And compliance alignment keeps everything consistent and also UN-wide responsible AI guidance. And here's how this role map into the actual team. So we break it down into 3 different teams. The AI and Knowledge Oversight Group provides strategic, ethical, and also operational direction. The program data focal point validate outputs and also maintain metadata, while the ICT system administration owns access, security, and also reliability. Together, they form this stewardship model that ensures accuracy, trust, and also long-term maintainability. Coming into the pilot, we would focus on one program branch or one workflow. So it's either strategic meetings and also programmatic activities. This keeps the scope actually tight, realistic, and also aligned with the current capabilities. The goal is actually not to automate everything all at once, but it's to bring a working version of the institutional snapshot assistant to life with a controlled pilot group and also 10 to 15 validated golden queries powered by real ingested data. And this gives UN something tangible, usable, and also meaningful to test while creating the foundation to expand to more workflows later on. And then next, we structured the roadmap into 3 different phases. So the first phase, builds the foundation. This will include, for example, alignment, taxonomy, schema, and also identifying champions. Phase 2 is the technical and change build. This includes SQL setup, migration, golden queries, and also the agent and the first UI. And then the last phase is where we activate the governance, we train staff, and we roll out the pilot, set KPIs, and also hand over documentation for the sustainment. And if the organization follow all of this approach, 3 outcomes become very possible. Number 1 is consistency, because there will be shared metadata and workflows across the team. And then the second is also confidence, because staff can rely on the agent's answers. And then the third is continuity, where the UN basically can sustain and also scale the system across other units.
So finally, continuing on the fourth and the last segment, which we covered, which is on continuous improvement, which deals with the metrics, success metrics, and what does it looks like to us. So if people at the end user are able to use and search the things from a UI itself without reaching out to someone for any details, that's a success criteria for us. Similarly, if we have a data being consistent with the metadata at a unified platform, it would be great to build more agent and have an agentic AI kind of infrastructure in future. And also we want a user feedback so that we can always train the model to work accordingly, best fitting the criteria, how the organization goes.
All right, and finally, this is important to note that this project is not a dead end, but it opens up significant possibilities for future projects. Starting with the unified knowledge base, there'll be every knowledge would be in one place, which can be used to link with other models or platforms. Next is like scalable. So since this model is highly scalable horizontally, so you don't have to like consistently first structure your data and then build the AI. You can start off with a little bit of data and then you can add more agents, you can add more databases. This is already, as mentioned before, embedding ready. So there's another layer in our blueprint which mentions about the RAG pipelines and embedding-based search, which this architecture supports. This is my most favorite point, is that there will be a single connection to all the KPI and BI dashboards, so you don't have to manage separate connections or just go change one file. You can change one thing in the database and it will be reflected all throughout. And finally, since everything is grounded in structured data, the consistency in reporting will be unmatched. And finally, we would just like to thank you, our instructors, for their valuable insights. And again, to our sponsors for being here. Let's see the future together. And one more thing to note, this model is scalable across all the units in the United Nations. Thank you so much.